Now let's talk about the very first type of factoring, other than factoring out of GCF, which is factoring by grouping. Factoring by grouping is useful when you have four terms, so notice the one here. The very first question you always want to ask yourself, I don't care what type of factoring it is, and we're going to talk about a lot in Unit 13, you always want to look for a GCF first. So is there any factor that you could take out of all four of these? And the answer is no. But when you have four terms and nothing factors out of all of them, think of factoring in pairs. To factor in pairs, you want to split the expression into two pairs of terms and then factor the terms separately. So let's look at an example of what this looks like. This first one here, you've got 6x to the third and negative or minus 9x squared. That would be your first pair. So notice how I divide this. I'm going to split it right down the middle. And then this is going to be my second pair over here. So basically we do the same thing we just did factoring out of GCF. We just have to do it twice. So what's the GCF here? Well, 3 goes into both of them. X squared would be my lowest variable. So to get me back here would be 2x. And then this would be minus 3. Now I'm going to factor out a GCF of 4x minus 6. They both have a 2 in common. So they don't have any variables in common, so you can't take that out. So 2 times 2x would bring me back here, and then this would be minus 3. So notice what this looks like. Doesn't this look like when you have a term as your GCF? So we can rewrite this just like we did previously. My GCF of all four of these would then be 2x minus 3. What is 2x minus 3 being multiplied by? It's being multiplied by 3x squared, and it's being multiplied by plus 2. Let's do this one. Now, you want to scan down and make sure there's no GCF of all four. There is no GCF of all four of these, so I'm going to split it down the middle. Now I can take out a 5 and I can take out an x. To get back to here, we're going to multiply by y. To get back to here, we're going to multiply by minus 3. Now, I gave you a hint down here, put a star beside it. It says if the first term of one of the pairs is negative, factor out a negative. So really it's all dependent upon this guy right here. Now notice this one was positive. I really didn't have to worry about anything. If this guy here is negative, you need to take out a negative as your GCF. So instead of just taking out 6, I'm going to take out negative 6 as my GCF. So what does this bring me back to? That just brings me back to y here. Now think about negative 6 times what brings you to positive 18? Well, negative 6 times negative 3 gives me a positive 18. Again, the whole reason why we have to take out this negative is because you always want these to match up. If they don't match up, typically you probably did something wrong. Otherwise, though, it could be a prime polynomial. So I can rewrite this as y minus 3 times 5x minus 6. So I want you to pause this video. I want you to try some factoring by grouping on your own, and when you're ready, hit play to check your answer. So no GCF of all four, so I'm going to split it down the middle. I can take out a 3 and I can take out a y, which is going to leave me x minus 7. I can take out a 5, which is going to also leave me x minus 7. So I can rewrite this as x minus 7 times 3y plus 5. Split it down the middle. I can't take out any numbers, but I can take out an x squared. This is going to leave me with x plus 3. Now right here I can take out a negative, so I can take out a negative 3, which is also going to leave me with x plus 3. So rewriting this, I've got x plus 3 as my GCF. And then you always write what's outside the parentheses next, so this would be x squared minus 3. All right, so everything we're going to be factoring now is going to be in the form of a quadratic. So a quadratic comes from the word quad, meaning square, because the variable that starts off is an x squared. So the first type of factoring we're going to be doing is when you have a polynomial where it just starts out with x squared. There's no number out front, so this is what it means by a is equal to 1. You don't see anything written in front of x squared, there's just nothing there. So the first thing you want to do is write the polynomial in descending order. So it always should start off with x squared plus or minus something x and then some number over here. That's in descending form. You want to factor out a GCF if there is one. You're going to hear me say GCF probably a million times in this unit because if you have a GCF, that's always your starting point. You write two sets of parentheses. You got to determine which two terms will multiply to give you the first. You write those in parentheses. And then which two terms will multiply to give you the last, but then add to give you the one in the middle. And then you want to write them second inside parentheses. You always want to check your answer by distributing or folding back out. You should never really get these wrong if you check your answer. Now, there are some cases where these are prime, so if you can't determine what multiplies to give you the last but adds to give you the middle, then that would be an example of prime. Probably this didn't mean anything to you, so let's look at some examples. So, step one, is there a GCF? Can I take anything out of all three? The answer would be no. They don't have a variable in common, they don't have a number in common. What you really want to pay attention to here is what multiplies to give you the last. So in this case, we would say, well, what multiplies to give me 6, but then adds to give you the middle? So I always like to come over to the side and say, okay, I'm looking for two numbers that multiplies to give me 6, but when I add them together, it should add to give me 5. Well, lo and behold, 3 and 2, positive 3 and 2 will add to give you 6, and it'll add to give you 5, but multiply to give you 6. So we draw our two sets of parentheses. Now what comes first? X times x gives you x squared, and 3 and 2 will multiply to give you 6, but it adds to give you 5, and this positive 3 and positive 2. So let's look at another one. There's no number in front of x squared, keep that in mind. What multiplies to give you 15, but adds to give you negative 8? Well, be careful, this is negative 8, this isn't positive 8. So notice a negative 5 and a negative 3, those two multiply to give you a positive 15, but they will add to give you a negative 8. So I draw my parentheses. X times x gives me x squared. Negative 3 and negative 5, it does not matter what order you write them in, by the way, will multiply to give you negative 15 and add to give you negative 8. Now be careful with this one. Is there a GCF of all three? Yes, there is. You always take out a GCF first. So keep in mind, GCF first. That should be your first question that you ask yourself. I can take out a 2 from all three of these. So that's going to be my first step. Remember, this is what we were doing at the very beginning. 2 times x squared gives you 2x squared. This is going to be minus 6x. And then 2 times 16 is what brings me back to 32. I'm not finished though now, because now I have to look in here and say, well, can I factor what multiplies to give me the last, give me the middle? Well, negative 16, what multiplies to give you negative 16, but will add to give you a negative 6? You could do a negative 8 and a positive 2, adds to give me negative 6, multiplies to give me negative 16. Notice how I write my answer though. That GCF that I took out at the beginning has to be a part of your answer. You always bring that GCF down. So now I'd have x times x gives me x squared, and then negative 8 and positive 2. So my final answer is 2 times x minus 8 times x plus 2. All right, pause the video and try some on your own. When you're ready, hit play to check your answer. So what multiplies to give me 42 but adds to give me 13? That would be 7 and 6. Again, there's no GCF of all three here. So my final answer would be x plus 7 and x plus 6. No GCF here. So what multiplies to give me negative 6 and will add to give me a positive 5? A lot of students think it has to be 3 and 2, but that's not going to work here to give you a negative 6 and adds to give you 5. So notice you can also do 6 and negative 1. Multiplies to give me negative 6, adds to give me a positive 5. So I would have x plus 6, x minus 1. Stop right here in your tracks. There's a GCF of all three of them. Take that out first. That's going to be the biggest thing, I promise you, is forgetting to take out that GCF if there exists one out of all three of these. So what multiplies to give me 8 but adds to give me negative 9? You could do a negative 8 and a negative 1. So I would have 5, x minus 8, x minus 1. Now, what happens when you have a number that's out front? Uh-oh, this method no longer works anymore. Now you're like, well, I can't just draw my little parentheses and do x times x, because x times x is not going to bring me back to 5. So you're like, well, I'll do 5 and 1. Well, think about how this distributive property works. This 5x gets multiplied by everything. And so you're like, whoa, oh my gosh, I got to come up with something that adds to give me here, multiplies to give me here, but it's also got to multiply to give me 5 here. Oh, look at all these question marks. That's exactly what happens. So let's take this same problem. So this is 5x squared plus 4x minus 12. Let's go through kind of the steps here for factoring when there's a number in front of x squared. You do want to always check for a GCF. There isn't one. This is called the AC method of factoring. Now, the AC method will also work when there's not a number in front of x squared. So if there's something that you need to know more than anything else, it's going to be the AC method. So it says determine AC by multiplying A and C together. So this is A, this is B, and this is C. Well, AC in this case would be 5 times negative 12. So 5 times negative 12 is going to give me negative 60. So now it says find two, this part should sound very familiar to you. We are looking for what two numbers are going to multiply to give me AC, but add to give me B. So the first step is the part that's different. I multiply 5 and negative 12 together, but I'm still looking for a number here that would add to give me 4. So let's think, what two numbers are going to multiply to give me negative 60 but add to give me 4? Well, you could do 10 and negative 6. That will add to give me that AC here, but it will, it will add to give me 4, but it will multiply to give me this AC here. Now we have to rewrite our equation. So remember, the original equation was 5x squared plus 4x minus 12. What we do is basically take these two numbers here, and instead of 4, we plug in these two numbers for 4. The first term and the last term stay the same, but I'm going to rewrite 4 as plus 10x and then minus 6x. This is the same thing as this. Now, what we can do is factor by grouping. So I'm going to split it down the middle. I can take out a 5x, which is going to leave me with x plus 2. Since this guy is negative, I have to take out a negative 6 as my GCF. And lo and behold, that's going to leave me with x plus 2. Now I can rewrite this polynomial as x plus 2 and then 5x minus 6. That is factoring by using the AC method. Let's look at a couple more examples here. I'm going to do 15 times 6. Now there's no GCF of everything, so when I do 15 times 6, that's going to give me, should give me 90. So 15 times 6 gives me 90. I'm looking for two numbers that will add to give me 19, so I could do 10 and 9. What do I do with 10 and 9? I take 10 and 9 and I plug them in for 19. So I rewrite this equation as 15x squared plus 10x plus 9x plus 6, split it down the middle. I can take out a 5x, which leaves me with 3x plus 2. I can take out a 3 between these two, which lo and behold leaves me 3x plus 2. So I can rewrite this as 3x plus 2 times 5x plus 3. Is there a GCF of all three? Yes, there is. Take it out first, I promise. So take out a 2, which leaves me with 3x squared minus 5x, and then minus 2. Now I can use my AC method, so I need to multiply 3 times negative 2 together, which is negative 6. What adds to give me negative 5? Well, I can do a negative 6 and a positive 1. So I'm going to rewrite just this part right here as 3x squared minus 6x plus 1x and then minus 2. Factor by grouping, I can take out a 3x, which leaves me with x minus 2. Now, if you can't take out anything here, always take out a 1, which lo and behold leaves me x minus 2. Now, when I rewrite this problem, I gotta write that GCF as part of my answer. So it's going to be 2, and then x minus 2, and then 3x plus 1.